In today's lesson, we are going to be introduced to another design pattern, that is the component pattern. Okay, if you don't have yesterday's lesson, just download it from this link. And we are going to use some images in order to customize the enemies and the NPCs in order to better differentiate them. So you can either download your own image or just download it from here and place them in the folder images. The first example that we are going to see of component pattern will be of the script patrol waypoints. First of all, we are going to keep exploring the design patterns because they help us to create a more modular and independent code that can grow in a more clean and scalable way. The design pattern known as component is something that we have been using all this time. A component pattern is a script that is added to another object and provide some additional functionality. We have been doing this all this time with our game objects, adding the components, box collider, rigid body, and our own scripts. So what we are going to do is that we are going to create a new script that will be another component pattern that will perform an action related with the artificial intelligence, that is to patrol through a collection of waypoints. This component will be attached to any element that requires from patrolling through a collection of waypoints, like an enemy or an NPC, or even later on we will apply the patrolling concept to just inanimate objects like the spikes. So we are going to go to the code and we are going to start first by creating a new script called patrol waypoints into the folder I. Okay, so go to the folder I and create a new script called patrol waypoints. The next thing that we are going to do is create another new script called waypoint inside the folder I that will contain the information about a single waypoint. Okay, so in this folder, just to create the script, and in this case is waypoint. Next, in the definition of waypoint, we are going to specify 3 public variable members that will allow us to create the waypoint definition. So copy paste and take them to the waypoint. Okay, so the first one is the target that will make reference to the game object that we will create on the scene to make reference to the waypoint we want. The position will be the position that of that same waypoint, and the duration is the time it takes the element to go from one waypoint to the next. Next, we are going to declare this class as serializable. Okay. The way to do it is just like this, and remember to import the necessary libraries to make it happen. And delete mono behavior, because what we need is just this data structure. Okay, so we don't need anything inherited from mono behavior. Only we need to keep this information right here. Next, back to the script pattern waypoints, we are going to declare public and private member variables in order to make reference to the list of waypoints that we are going to create. Okay, so just copy paste these public and private variables, and what they are is first of all the array of waypoints that we are going to use for our behavior to work. This is the index of the current waypoint that is transitioning the component who has attached this behavior, and this boolean will tell us if the behavior is activated or not. So now in the start method, we are going to initialize the position of each waypoint. Okay, so just copy paste on the start. And the only thing that we are doing right here is just to go through all the waypoints, okay, all the array of waypoints, and initializing the data about its position with the data of the target. After that, we proceed to destroy that game object so they are not in the way. The next step that we are going to do is that we are going to do the finite state machine for this behavior. So when the behavior of this component is activated, it should synchronize by going to the current waypoint. Okay, so when this behavior is just activated, the game object that has attached this behavior should go to the current waypoint. Once it has synchronized, it will go through all the waypoints, one after the other. When it reaches a waypoint, it should update the current waypoint, okay, and go to the next waypoint. In order for to do the finite state machine, you can use this diagram, okay, and well, just remember how we did the finite state machines. This is just a reference of what we did to define the finite state machine for the enemy. So take this as a reference and just create a finite state machine that behaves like I have described. Okay, so go ahead and do it. And the result should look similar to this. We have a first synchronization state where we will move to reach the current waypoint. Once we have reached the current waypoint, we will start to go through all the waypoints that we need to go. So we will update the waypoint, and once the waypoint has been updated, we will change the state to go to waypoint, where the component will be moving until it reaches the next waypoint. The moment it reaches the next waypoint, the waypoint will be updated again to go for the next and the next and the next. Okay? So next, what we are going to do is just continue with the process of converting from a finite state machine diagram to the code, and the next step in the sequence is to create the table diagram. Okay, so you can download the template from this link. Okay, and you can import this template from the diagram editor. And you can start filling this table. Okay, so go ahead and do it. Okay, and the result should look similar to this. We filled both the rows and the columns with the states that we have identified. Okay, And for the synchronization state, the action that we are going to do is just to walk to the current waypoint. Okay, once in the synchronization state, when we have reached the waypoint, we will transition to the update state. Okay, once we have reached the waypoint, transition to the update state. Next, in the update state, we are going to increase the waypoint to the next waypoint, and we are going to change to the next state. Next, on the go to waypoint, if we are on the same state, the action that we are going to do is just to walk to the current waypoint, and once we have reached that next waypoint, okay, then we can proceed to change to the state update waypoint, so we update to the next waypoint. Okay, so that way we have translated from the finite state machine diagram to the table design diagram. Okay, next step would be to create the pseudocode. So go ahead and do it. And the result should look similar to this. Okay, we are evaluating the state, and we have created the skeleton, okay, with the three cases, with the three states, okay. And for the case synchronization, okay, the action that we are performing is walking to the current waypoint. Okay, so we are doing the action. From synchronization, we transition to update waypoint when we have reached the waypoint. Okay, so if we have reached the waypoint, we change the state to the update waypoint. Okay, and in the update waypoint case, the actions that we are going to do is just to update the waypoint and directly transition to the next state. Okay, so what we are doing here is just update the waypoint, control that if the index of the waypoint goes above the total number of waypoints, then it should reset to the initial waypoint. Okay, and we transition directly to go to waypoint. Finally, on the state go to waypoint, the action that we are going to do is walk to the current waypoint. Okay, so we do the action, and the condition is that if we have reached the next waypoint, then we proceed to change to the update state again. Okay, so if in the go to waypoint state, if there is the transition, go to the update waypoint state. But before implementing the code, a question: is there a class that we could use to inherit the state behavior? We have our class state machine, right? That we were already using in the game controller and also in our avatars. We can also use it right here. Okay, we can also use the state machine right here, so we can take advantage of the finite state machine to define just the finite state machine that we have done. So next, what you are going to do is just to implement the code skeleton. That means the switch in the update, covering all the cases, and all these methods empty. Okay, all the methods just empty. So go ahead and do it. Okay, and the solution should look similar to this. We have started just by moving all our pseudocode to code, just creating the whole skeleton of our script. We have created the 3 cases, and for the 3 cases we have defined 3 constants. Okay, and we have filled each case with the behavior we want to run in each case, and for each method we have implemented the method just empty, because the next thing that we are going to do is just to implement both methods. Okay, and finally we have just extended the changes state in order for to be able to run operations just in the moment that we are just changing the state. Before continuing, we are going to do a small change. We are going to introduce this line of code in the update. Okay, and what this line of code will do is just to control if we want to run the behavior, okay, the finite state machine behavior for the patrol waypoints, or if we don't want to run it. Okay, so thanks to this private boolean, we will be able to control if we run the behavior or not. So now we are going to implement the functions. We will start implementing the function reached current waypoint. And in this function, we will calculate the distance between the position that the character currently is, okay, against the position of the waypoint he has to go. Okay, so tips. Remember that this is a component pattern that we should add to the game object we want to apply this behavior. Okay. Second tip is that use what offers Unity in relationship to calculate the distance between 2 vectors, that is vector 3 distance, and just access the property position from the class waypoint. So go ahead and do it. And the result should look similar to this. So we have started with the conditional if, and we are calculating the distance from the current position, and we are retrieving that position by accessing the property this, the transform, and the position. Remember that this script is going to be attached to a game object, and we will have access to that information, to the information of the game object, through the property this transform, and we get the position. Once we have the position of the object, we calculate the distance to the next waypoint. Okay, in order to get the next waypoint, we have the index of the position of the array that is going to be the next waypoint. Okay, we access to that position, and we access to the property position that belongs to the structure of waypoint. Okay, once we have calculated the distance, we compare this distance to just a value. I have used the value 1 because it's a value that it's low enough to consider that the element is close enough to the waypoint in order to consider that it has reached the waypoint. So if it has reached the waypoint, we proceed to return true. If it hasn't reached the waypoint, we would proceed to return false. So next we would be implementing the wall to current waypoint, okay? But in this case, the functionality is maybe a little bit complex, so I give you the option that if you want to implement wall to current waypoint, you can do it, but I am not forcing you to do it, because I am going to provide you right now with the solution. Because the solution maybe it's a little bit too complex in this stage right now, so don't worry about it. And well, we are going just to copy paste this code. Okay, so we are going to get this code, paste it, and I am going to explain it. Okay, so we are implementing the method wall to current waypoint. It's a method that we have used in our finite state machine, and the goal of wall to current waypoint is that well, the game object that has attached the pattern waypoints will move towards the current waypoint. Okay, and that's what this method is going to do. So what do we have here is that we keep track of the time in the first line, and if you recall, when we define the structure waypoint, we define a public member variable of type float called duration. Duration is the time that it takes to go from one waypoint to the next. Okay, so that's what we are doing here. We are just getting the duration, and with that information we're implementing a way so the game object who has attached the patrol waypoints go to the next waypoint in this specified duration. Okay, so what we are doing here is getting the duration, and we are retrieving the previous waypoint. Okay, next we are getting the forward vector to go to the next waypoint. Here we are just getting the fraction of the step that must do in this frame. Okay, in this cycle. Here we are getting the next position where it should advance the game object who has attached the patrol waypoints, and finally we are using the rigid body, the method move to position, to specify the position we want to move the game object. Okay, as I said, this is maybe a little bit complex at this stage, so I would prefer that you just understand that. Okay, wall to current waypoint is a method that will help me to move the game object from one waypoint to the next in a duration of time. The next thing that we are going to do, we are going to correct a mistake that I have made. Okay, and this mistake has been on purpose, and the reason why I have made this mistake is in order to ease the process of understanding this patrol waypoints behavior. So what happens is that in the synchronization state, what we want to do is that, okay, we want that the game object who has attached this patrol waypoints script just to go to the current waypoint. But if you remember, in the method wall to current waypoint, we are just calculating the position between two waypoints. Okay, so in the synchronization state, we don't know where is the player. The player can be far away, so we cannot use this method wall to current waypoint, because this method is when the game object is already in the cycle to going through all the waypoints. So we need to implement a new method. This new method, we are going to call it walk with a speed to waypoint. And what is going to do this method is just to walk with a certain speed to the current waypoint. Instead of using this method, we are going to create a new one. It's an easier method, okay, and it's something that you have already seen. And you are going to move the game object towards the current waypoint in a certain speed, okay, and the moment it gets close to that waypoint, it will start the iteration between waypoints, and in that moment will be the method to call to go through all the waypoints. We are going to create a new public variable in the patrol waypoints script that it will be a float called speed. Okay, so let's go to the code, and we are going to create another public member variable called speed. We can initialize it with a value, for example 5, and we would be able to customize in the Unity inspector this value. Okay, this is the value that we are going to use to move the game object who has attached the patrol waypoints script towards the current waypoint. Okay. Now you are going to implement that method that will move the character who has attached the patrol waypoints script with the speed that we have just implemented towards the current waypoint. Okay? Remember that we have already used the apply movement to an object with a speed and a direction vector. So just check previous examples to implement this method. So go ahead and do it. Okay, and the implementation should look similar to this. We have calculated the direction vector between the target point, that is the current waypoint position, and the current position of the game object who has attached the patrol waypoints. We have normalized the vector in order to be able to use it. And here we are just calculating the next position, taking the current position plus the direction vector, multiplied by the speed and adjusted by time delta time. Okay, that will give us the next position to move this component with the speed we want. Okay, and finally what we have done is to use this method in the update, in the synchronization state. So when the element that has attached this script activates the behavior patrol waypoints, the first thing that is going to do is start with a synchronization state where it will move towards the current waypoint in the speed we have defined right here. Okay, once it has reached the current waypoint, it will start going through all the cycle of update and go to waypoint. Before going back to the Unity editor to start creating waypoints, we are going to introduce two public methods in the patrol waypoints class. So go ahead and copy these two methods and place them in the patrol waypoint class. And what these two methods will do is the activate patrol will have a parameter called speed that will set up our speed. Okay, and it will set our private member boolean that we are using just to control if we want to run or not the behavior. Okay, we activate this boolean in order to activate the behavior. Finally, we are changing the state to synchronization state in order for the full behavior to start. Okay, and the other public method that we are creating is the activate patrol, that it just changes our m-activated boolean to false in order to prevent from running the behavior. And now we are going back to the Unity editor. Okay. And here we are going to add the patrol waypoint component to an enemy. So go to the folder where the level prefabs are. Okay. Select the level 0. Okay. And we are going to select, just start with this first enemy. Select it. And we are going to add to this enemy the component patrol waypoints. Okay, let's move the inspector right here. So in order that it's not in the way of the lesson, okay? Now add 4 entries into this array, okay? We have created right here 4 items that we are going to fill, and we are going to fill them with 4 spheres, okay, that will represent the waypoints that this particular enemy is going to go through. So create inside the game object of the enemy 4 spheres, okay, go here and create the different spheres. 1, 2, 3, and 4. Just rename them for the sake of making more readable, okay? And once you have created all of them, just fill the array with each one of them, okay? Here, another here, another here, and another here, okay? So the next thing that you are going to do is just to assign the duration that you want that it takes from one waypoint to the next, okay? So the duration is going to take from one waypoint to the next is going to be defined in the next waypoint. So from 0 to 1, we can set 4 seconds. From 1 to 2, let's for example 6 seconds. From 2 to 3, let's say 2 seconds, and from 3 to 0, let's put it just 1 second, for example. Okay, we are going to go back to the code now. And here in the enemy script, we are going to make reference to the patrol waypoint component. But before doing that, we are going to rename the state called check for player with the new name patrol and check. Okay, so go to the code, and for this state, for this constant, you are going to rename it, and instead of check for player, you are going to name it patrol and check. And in all the places that we are using this constant, it would have changed, okay? Okay, so next, what we are going to do is we are going to add a new private member variable that will be the reference that will connect with the component patrol waypoints, okay? And now on the start method, you are going to get that component, okay? So in order to get that component, use the method getComponent, and getComponent comes from the object this. So we are getting the patrol waypoints, but you have to consider that not always you are going to get the patrol waypoints, because right now we only have attached the patrol waypoints component just to this enemy, okay? So only for that specific enemy we are going to get the patrol waypoint component. For the rest, this value is going to be null. The next changes that we are going to do still in the enemy script will be on the change state method. For the case patrol and check, we are going to run this conditional, okay? So go to the change state, and in the patrol and check, instead of this code, you are going to run this other code, okay? Just update the name to be the right one. And what we are doing just right here is that we are checking with a conditional if there is a reference to the patrol waypoint component. As I have said, not always we are going to get the reference to the patrol waypoints, because not all the enemies have the patrol waypoints component, only this one. So for these cases, when they try to get this component, it will return null because there is no component for these two. So we have to consider that case. And that's what we are doing here. We are considering that if there is no component patrol waypoints, then we run the previous behavior. And the previous behavior was that when we go back to this state, we updated the initial position to a random one. But in the case that we have found the patrol waypoints component, then in that case we can activate the patrolling. Okay, just remember that we created a public method where we just set the speed of the movement of the element in order to go to the first initial state. We activate the Boolean variable that allow us to run this code, and finally we change the state to synchronization so the initial state of synchronization can run. The next change that we have to make is that for the enemy script, for the case of GoToPlayer. Okay, for this case, what we are going to do is just to deactivate the patrolling if this enemy has the component patrol waypoints. Again, we have to check if the enemy has this component, because if it doesn't have this component, this call right here would cause an exception, a problem. Okay, and we don't want that. Okay, so we have to check if there is this component. Okay, we can use it, and we should use it by deactivating the behavior, because you have to consider that when the enemy transitions to this state, it's because the player is inside its detection range and the enemy should go towards the player, and this behavior should stop running. That's why we are deactivating it when the enemy is going towards the player, and we are activating it again when the player, the enemy, just go back to this previous state. The final change that we have to do in this case is in the update method. It's in the patrol and check, and what we are going to do is that in the patrol and check, in this state, the action that we are doing is go to initial position. Okay, so what we are doing is that when we are in that state, we are moving towards the initial position. But we are not interested to do that when the enemy has a component patrol waypoints attached to it. Okay, so what we are going to do in this case, we are going to check that if there is no patrol waypoints component, then okay, you can proceed to run the previous behavior. Okay, and that would happen for the cases of the enemies that don't have the patrol waypoints component. But in the case of this one, it will happen. It won't run the go to initial position. Okay, so if we did it right and we proceed to run, we should be getting, okay, we are not getting the enemy patrolling through the waypoints. So the error that I have made is this one. Okay, so what is happening here is that I am only going to run this code only when the previous state is different from the initial state. Okay, so if I come from this initial state, this code is not going to run. Okay, and that's a problem because we need to activate the patrol waypoints in in this state. Okay, so we are going to fix that. We still want to update only this position when we are coming back from any go to player and shoot to player state. Okay, so this code of here we can keep it. Okay, and we have to consider that this code will only be considered when we don't have the patrol waypoints component. Okay, so we are going to put this inside here. So, okay, we don't have the patrol waypoints component. We proceed to run the previous code that was checking if that we don't come from the initial state. We just update the initial position to a random position as we did before. But if we have the patrol waypoints component, then we just proceed to activate it. Okay. Now save it, go back to the editor, and now we should have the behavior we are looking for. We press play, and you can see the enemy transitioning from the different waypoints. Okay. Every time that the enemy is close to a waypoint below a distance of 1, it's updating its position and it's transitioning to go to the next waypoint. Okay. Now, if we get close to the enemy, the behavior we initially programmed for the enemy will be triggered. So let's get closer. Okay, and now you can see the enemy is back to the initial behavior where he was looking for the player, and when it detected that it was in its detection range, it proceeded to run towards it and shoot bullets. Okay, so let's go away from the enemy, and the enemy now is going back to the current waypoint, and in a moment is going to transition between all the different waypoints with the times we have previously set. Okay, so the patrolling waypoints is working fine. So we are about to conclude this first part of the introduction to component patterns, with the introduction of the patrol waypoints component, and just summarize that what we have done. So we have done our component pattern patrol waypoints that we have then added as a component to the enemy game object. And well, we have created a collection of waypoints, and then with the patrol waypoint component, the enemy was able to patrol through this collection of waypoints. Okay, so now you are free to keep adding patrol waypoints components both for enemies and also for NPCs. Okay, so please consider what changes do you need to do in the code of the NPC for the patrol waypoints component to work also in that class. Okay, so go ahead and do it. The next component pattern that we are going to see will be the component pattern called rotate to target. And what this component pattern is going to do is it's going to rotate any game object that has attached this component. It will rotate towards a target. The idea behind this component is that we can rotate our enemies and NPCs towards the player. So what we are going to do now is going back to the editor. We are going to create the script in our folder I. Okay, so let's create the script right here. Rotate to target. Okay, let's open the script. And we are going to add 3 public member variables, these ones. And what do they mean? The first one is the target that the game object who has attached this component is going to look to. The rotation speed will be the speed in which the attached component is going to rotate towards the target. And finally, we have, as we did before with the patrol waypoints, a Boolean variable that will allow us to control if we enable or disable this behavior. We are going to implement the update method, and what should happen in the update method is that the transform that has attached this rotate to target component is going to just rotate to the target. So just search using this text and look for a solution in order to implement the rotation towards a target. Okay, and the solution should look similar to this. The first thing that we are going to do is just to calculate the directional vector from the target to the current position. It's the directional vector to go towards that position. We are going to reset the y-axis because in this particular case we are only interested that the enemies and NPCs that are going to have this component, we want only that they face us, and we can do that just by ignoring the y-axis. Okay, and for this directional vector we are going to calculate its quaternion. Okay, so this is going to return a quaternion, that it's the information you need in order to rotate the transform of the attached object to the desired rotation. So what we are doing here is we are doing some operations related to interpolation related to rotations, that they are provided by the library, mathematical library of Unity, and you can just trust that Unity is going to handle this rotation. So you only have to worry only about specifying the right parameters, and the right parameters are the rotation of the current transform, the target rotation, and you have to specify here the time delta time and the rotation speed. With this information, you can Unity can calculate the interpolation values in order to create a smooth rotation towards a target. And now what we are going to do is just to create the methods that will allow to activate and deactivate this component. Okay, so you are going to create a method activate rotation, and this method will have just one parameter that would be the position where this component should rotate towards. Okay, and also this method should activate this behavior and set this new target with the parameter value. The other method is the deactivate rotation, and it will deactivate this behavior. Okay, so as tips, just check the activation that we did for patrol waypoints and take it as a reference, because it's really similar of what we need to do here. Okay, so go ahead and do it. Okay, and the code should look similar to this. We have created our public method activate rotation with one parameter that it's the position where this component should rotate towards. We have set up the target with that information, and we have activated the behavior in order to run this component. Okay, and for the method deactivate rotation, we are just only deactivating the behavior. So now we are going to go back to our component patrol waypoints, and we are going to connect both components, the rotate to target script and the patrol waypoints. They are going to work together. So back to the patrol waypoints component script, we are going to create a member variable that will make reference to our component rotate to target. Okay, so right now find out the place where you can get the reference to the component rotate to target. So do it. Okay, and the way to get if the game object that has attached the patrol waypoints has also the component rotate to target is by accessing the property this. So we are accessing to the object that has attached the patrol waypoints, and we are asking if we have also the component rotate to target. If we have the component, we will get the reference. If we don't have the component, then this value would be null. Next, find out where you can activate the rotate to target component in order for the game object who has attached the patrol waypoints face the waypoint it is going to. Okay, so do it. And the solution should look similar to this. In the exact moment that we are updating the index of the waypoint we are going next, in that specific moment, we just activate the rotate to target component with the target of the next waypoint that we are going to. That way we are activating the rotate to target component, and the game object will face the next waypoint. And finally, create a function called isThere_rotation component that will return true or false if we have the component rotate to target in the game object, and use this function in order to check if there is the component, and if there is not the component, don't activate it. Okay, so go ahead and do it. And the result should look similar to this. We have created our function that checks if the rotate to target component is there. If it's there, this will return true. If it's not there, it will return false. And we are using that function in order to check before trying to activate. In the case that we don't have the component, we are not going to activate, because this could cause a null pointer exception. Next, we are going back to the Unity editor, and what we are going to do, we are going to create to add a capsule inside the enemies. And this capsule will do as the nose of the enemy, so we can have a reference of where it's facing the enemy. Okay, so just select the level, select the enemy who has the patrol, any of the patrol waypoints, for example, this first one. And we are going to add the component rotate to target. Okay, let's collapse this list so we can see it better. Okay, rotate to target. And now for this enemy, okay, we are going to add a nose for it. Okay, so we are going to add a 3D object, a capsule. Okay, and this capsule we are going to move it, and we are going to orient it in order to make a nose for this game object. Okay, something like this, smaller. Okay, we are going to try to find out where is facing the enemy. Okay, so what we can do just right now, we can proceed to play. And okay, as you can see, well, the enemy right now is let him patrol through the waypoints. It seems the rotation speed for the rotate to target component is not enough. So we are going to adjust it. Let's make it faster, like this. Faster. Okay. Okay. Now is facing the next waypoint where it's going. Okay, so we are good. Okay, so the next exercise that we are going to do is that we are going to use the component rotate to target in order for the enemy to face the player when it detects it. So go ahead and do it. Okay, and the solution should look similar to this. What we have done, we have declared a new protected member variable of the type of rotate to target. I have placed it on the avatar because both enemy and NPC are going to use it, so I declare it at this level, so both enemy and NPC can inherit from it. And in the start method, I just get the component if it exists, okay? And in the enemy, what I am doing is just to, in the moment that I am going towards the player, I check if the component is there, if it's not null, and if it's not null, I activate the rotation with the target of the player's position. I do exactly the same when the enemy is shooting at the player. So if I proceed to play, now if we get closer to the enemy will face us. Okay, so let's do it. Okay, so you can see the enemy is facing us. Okay, if we move away, okay, so the last thing that we need to fix is that in the synchronization state we are going to change in order for when he goes back to the patrol waypoints, just to face the current waypoint. So do it. And the solution should look similar to this. Since the next patrol waypoint is something static that it's not going to move, we only need to perform this action only once. Okay, and the perfect place to perform this action only once is on the change state. The moment that we are changing the state to the synchronization, then we are checking if we have the component, and if we have the component, then we proceed to face the current waypoint that we should go to. If we proceed to play it, okay, we are going to trigger the player's detection for the enemy. So, okay, we are good, and we are going to get away. So the synchronization state is being triggered. So now, and you can see that now it's facing the next waypoint he should go, and he's going back to the patrolling waypoints. So the final exercise that you are going to do to finish with this component pattern is to add also the behavior of the rotate to target for the NPC. Okay, so you have to do something similar with the NPC of what we have just done with the enemy. Okay, and so go ahead and do it. Okay, and the result should look similar to this. For the NPC, what we have done is just almost exactly as we have done for the enemy. Since we have abstracted the behavior of retrieving the component in the avatar class, we don't have to worry about it. We are getting that the both reference, if they exist, both for the patrol waypoints and the rotate to target component in the start. And in NPC, we only need to use it in the right moment. So right moment is, well, when you are going to the player and you have the component, you rotate to the player, and the same when talking to the player. And the last thing that we have done is just to add that if the NPC or the enemy don't have the patrol waypoint component, if they go to the initial position, they are going to rotate towards that initial position. And that's what we are doing both for the state check for player for NPC and also in the patrol uncheck of the enemy. If we don't have the patrol waypoints component, the default behavior would be to go back to the initial position, and we would rotate to that initial position. If you proceed to run, you should have that behavior. Okay, when you are going, for example, we have one enemy without patrol waypoints and one NPC without patrol waypoints. So If you interact with the NPC, for example, you go away, then the NPC is facing the initial point that he should go. Okay, and the same would happen for the that enemy. Let's kill this one so it's not in the way. Okay, so we are going to, okay, the detection, the player's detection has been triggered for the enemy, and when we get away, goes to an initial position. Okay, let's trigger it again, and okay. Okay, so with this part we have concluded this this component pattern, the component pattern rotate to target. The next step that we are going to do is that we are going to keep extending the patrol waypoints component with more options. Okay, so we are going to keep extending the functionality of our patrol waypoints component. And the goal that we are looking for is that to have two actions to perform in the patrol waypoints component. We can have the option of going towards the next waypoint, that is the current behavior, but we are going to add a new action that is just to stay in that same waypoint. Okay, so what we are going to do is we are going to create a new public member variable in the waypoint script, and we are going to create a type enum, that the type enum allow us to create an enumeration, a basic type with multiple values. Okay, if you want to know more about how to use enumerations and in your project, I will link some good tutorials so you can learn more about it. Okay, for this case we are just going straight to the point, and we are going to declare an enumeration, actions patrol, and we are going to declare two entries, the entry go and the entry stay. And after that declaration of the enumeration, we are going to use this new type. Okay, and we are going to declare a public member variable called action. Okay, so go back to the code, and in the script waypoints you are going just to copy paste this whole thing. Okay, and if you go back to the Unity editor and you select a level and an enemy who has the patrol waypoints, when you expand the waypoints list, you should see that what we have just declared has appeared as a Dropbox with two values, go and stay. Okay, and we are going to implement the functionality in order to implement these behaviors. As a quick introduction for the enumeration definition, I am going to describe it like this. An enum allows us to create a basic type with a collection of finite values that we can use them in the variables. For example, for the previous action, we can do we can check that value, and in order to compare it, we can do it like this. We define the declaration of the enumeration. In this case was actions patrol, and in order to compare it that previous member variable, we access to any of the elements of that collection. That way we can compare if the value that has action is equals to one of these values. Okay, we can also use it on a switch. We can just evaluate the public member variable, and we can just decide which case it is. Okay, so what we are going to do next is that we are going to implement that if the action selected is go, the action will be to go to the next waypoint as usual. But if the action is a state, the action will be to stay in that position for a duration of time. Okay? So now you're going to do the implementation in the patrol waypoints script in order for that to happen. As a first tip, just create a new state. Okay? This new state, call it stay in waypoint, and you will use that state. Instead of transitioning to go to waypoint, you will transition to state waypoint when the action is about to stay in. Okay? Second tip, when patrol waypoints is on the state update waypoint, just check if either it's an action of the type go or stay to decide what's the next state it should go to. And in the new state in waypoint, use the existing variable member time done to keep track of the time until the duration of the waypoint has been completed. That in that moment, just update to the next waypoint. So go ahead and do it. Okay, and the result should look similar to this. The first thing that we have done is to create the new state in waypoint. And what happens in this state is just that it waits. Okay, so it keeps track of the time that has passed. And when the time that has passed is above the duration we are expecting for, we just transition to the update waypoint state, where we will update to the next waypoint. The next thing that we have done is that in the update waypoint state, we are just checking what action do we need to do. If we need to do the action go, okay, we transition to the state go to waypoint as expected. But if the action is a stay, we are going to change the state to the state waypoint. Okay, so now we can go back to the code and let's do it just for one example. Let's do it. Let's make it simple. Let's make it for this enemy. Let's change it to a stay. Okay, and if we press play and go to check what's doing that enemy. Okay, so that enemy is doing something kind of unexpected. It's true that it's transitioning from one position right here to the other by moving towards, but he's staying and it's staying in that position, but then it transitions, it just jumps automatically, teleports to that position. So we are going to fix that. Okay, and the way to fix that is we are going back to the code, and what we need to do is in this function get previous position waypoint, we are this function was used in the walk to current waypoint. Okay, so what happened here is that it was used in order to calculate the interpolation between two positions. Okay, but they should be positions where the action was to go. Okay, since now we have to consider that the action stay is not the action go, we should look for the previous waypoint where the action was to go. Okay, so in short, I am going to do it for you, and what we need to do is just to look the previous waypoints for the last where we had to go, and we can do it just like this. So what we are doing here is, okay, we are interested to know what was the last waypoint where the action was to go. So we are just using that buckler in order to get that. I want to get that that position, and that's how we get it. Okay, I have noticed that I have made a mistake, and that mistake was this one. If we keep this value right here, this is not going to change, because this value here will always set this other value here as always the same. What we need to do is just that, well, set this value right here, use this value right here, and for each iteration this value is going to change. Okay, change until it gets the waypoint which has the action to go. Okay, so now we are ready to go back to the Unity editor and play. So let's check our enemy, how it's doing. Okay, it seems that still is not working. So the reason why it's not working, if we go now, we need to go to the level fab, and now what we need to do is to add a new waypoint. Okay, so the transition should be in here, and this should be to go, and we can use a time of 4. Okay, so we have added a new waypoint with the action to go, and just like this we would have restored the kind of original behavior plus the behavior of staying at that position. Okay, okay, so I have missed of waypoint, so if it's not this one, it should be this other one. Okay, let's try again. Okay, and now we are getting the expected behavior. We are patrolling between these 2 waypoints and waiting for 2 seconds on that specific position. What I ask you to do next is that you customize all the different enemies in any way you want. Just create waypoints to stay on them, and feel free to customize the whole thing any way you want. Okay, for example, I am going to do it for this particular case. If I am not wrong, this should be sphere 3, and let me check that. Okay, okay, now it waits, and okay, it transitions. Okay, so try to do all the others who has the patrol waypoints component as a part of it, and feel free to explore any way you want. I was forgetting something. That was that, do you remember that we downloaded some faces? We have forgot to apply these faces to the avatars that we have on the scene, so let's go into that. Let's going to use these images to customize in a different way each one of the elements. Okay. And once you have done that, you should have a more fancy enemies and NPCs. The final thing that we are going to do in relationship with the component patterns will be to extend the behavior of the patrol waypoints in order to apply the behavior to objects which doesn't have a rigid body. So we are going to keep extending the patrol waypoints component. So far, we have used it to add patrolling behavior to the enemies who are affected by the physics and the gravity. And now we are going to move objects which doesn't have physics, like the spikes. The goal will be to use the patrol waypoints component in order to perform the typical behavior of the spikes going up and down. So first of all, let's go to our code. And in the script patrol waypoints, we will detect if the game object who has attached the script has the component rigid body. Okay, so we should store that information in a private member that we will call like this: M has rigid body. So do it. And the result should look similar to this. We have defined the private variable member of the type boolean, and the next thing that we have done is on the start method we are just checking if there is the component rigid body attached to the same object that who has attached the patrol waypoints. If this is different of null, then we have a rigid body, and the result of this operation would be true. Now, in the patrol waypoints script, there are two methods where we move the rigid body, and we have to check the previous variable in order to know what kind of operation we should apply. Okay, when the character has physics, we still apply the same behavior. We move the object through the rigid body. But when there is no rigid body, we should modify directly the transform. Okay, so do it. And the solution should look similar to this. We are moving the rigid body both in walk to current waypoint and walk with speed to waypoint. Okay, in both methods we are just getting the rigid body component and moving through the rigid body. And what we are going to do now is just check our previous boolean, where we keep the information if the game object who has this component has the rigid body, and if it has the rigid body, then we proceed as always. But if it doesn't have the rigid body, we are going to just modify the position directly. But before going back to the Unity editor and start adding the patrol waypoints component script to the spikes, we are going to do a small change. Okay, so what we are going to do is that in the method update of the patrol waypoints script, we are going to change the way that we are going to transition from go to waypoint state to update waypoint state. So far right now we are just checking the distance. If the distance to the next waypoint is below 1, then we update the waypoint. So what we are going to do now is just check by time. So if the time that we have done it's just above the duration, then we can proceed to update the state. So let's go back to the code, and we are going to transition from go to waypoint state to update waypoint state using the time. Okay, so just like this, because time done is being updated in wall to current waypoint. Okay, so we get the information from here, and in the state go to waypoint inside the update, when we have done the time of the duration, then we transition to the update state. By this way, it will be more precise to go from one waypoint to another. So now, since we are going also to use the patrol waypoints script as a component of the spikes, we also need that the spikes can get a reference to that patrol waypoints component. Okay, so what you are going to do is in the script spikes, in the start method, you are going to get the reference to the patrol waypoints and you are going to activate it. Okay, so do it. And the result should look similar to this. First of all, we have created a public member variable. First of all, we have created a private member variable that is a reference to the patrol waypoints component. And in the start method, we are asking the component attached, we are asking to the game object attached to the spikes if it also has the patrol waypoints component. And in case we have it, we get the reference here. If we have it, if this is different from null, we can proceed to activate the behavior. If we don't have it, then we would proceed as always. It would be just static states. It won't move. So now it's time to go back to the Unity editor, and we are going to add the component patrol waypoints to the spikes, and we are going to make it patrol through a collection of waypoints. Okay, so select the level 0, then go to the objects, enable the objects, and we are going just to get one of the spikes, for example, this one, and let's move it a little bit far away, just right here. Just it's easier to see. And we are going to add the patrol waypoints component script. Okay. Now what we need to do is that, as I have said, we are going to move the spikes up and down. So we are going to create just 2 waypoints for the moment, and we are going to create the waypoints, just creating spheres inside it. Okay, so the first sphere we are going to put it just below the ground, and the other sphere we are going to place it above the ground. Okay, so we have both waypoints, and the only thing left to do is just to assign them. Okay, so here we have one waypoint and here we have the other. And the time between waypoints, let's say that from the sphere to the sphere above the ground, we are going to go slower. So the speed to go to this sphere would be maybe 5, and to go above the ground would be faster. So we are going to choose 2. Okay, if we proceed to play, we are getting the expected behavior. Okay, so the spikes, an object that doesn't have rigid body, is moving as we expected. So now it's up to you to play around to move the spikes any way you want. You can move it up and down. You can move it diagonally. You can move it anywhere. Just for the sake, I am going to do it like that. We are going to do some more complex patrolling. We are going to choose another spikes, maybe this one, and we are going to move it in another position, maybe here. And for this case, we are going to create a more complex waypoint path. Okay, so we are going to choose 5 positions. We are going to create spheres that represent the waypoints for each one. Okay. Okay, so feel free to keep exploring. Okay, create as many spikes as you want across the level, and try to have a little bit of fun.